Alright, hey guys, Mr. Kyle Myers Mathematics. This is an example problem for a student again, so I'm doing a lot of specific problems for students lately. I don't know if you guys have noticed, but this is for a particular student. But of course, if you have a question about how to graph either y equals 3 sine 2x or 2 sine of negative 4x, then this is for you. I'm going to do part A in this video, and then in another video I'll do part B, just to kind of not have it drag on too long. So without further ado, we'll go ahead and do this. And this is a particular method. You can do it a different way if you want. If your teacher teaches it a different way and that's how they're grading it, then of course do it that way. I'm only going to show one way to do it here, just again for sake of time. So let's go ahead and jump in. I'm going to do yellow, I think, for this one. And before we actually do that, I'm going to do something else. I'm going to do, let's go and do a, let's do like a white color here, because I'm going to have the parent function. Actually, let me do something similar to the yellow. Let's do like an orange for the parent function. And actually, you know what? They both have parent functions, so yeah, that'll work out. If I do, you know what? Let's do that. Let's just have it be green. And then that way the green can be the parent function for both, because they both have the same parent function. They're both sine x. So I might just do this, actually. I might end up just graphing them both on the same coordinate axis to save time, to save even more time, because I'm all about saving time. So we're going to go ahead and draw these in here. Let's see, do I want to use this? No, I want to use a line tool. Here we go. So is that even going to show up? That's not even showing up. Hold on. Helps if I make it the right color. There we go. Okay. So, and I'm going to try to line this up to the grid. Can you guys see that grid? You can see that grid. It actually looks better. It looks better on the video than it does for me. There's a little bit of a glare on my end when I'm looking at it. So if you see me squinting, it's for two reasons. One, because I have a glare and you don't, and also because I need to get some new glasses and I keep putting it off. There we go. And our little y-axis going on there, and then we're going to do another one to make our x-axis. So here's our x-axis, and out to here is probably fine. There we go. Okay. With both A and B graphs, there are no phase shifts or vertical shifts. So the midline is going to be the x-axis, and the period will get altered. With both of these, the period is going to get restricted. The period is going to be, what is the word? Stretch and shrink. There we go. The period is going to be shrunk. Could not think of that word for a second. So I'm going to draw the y equals sine x to be a little bit longer, since I know that both of them are going to get shrunk down a little bit. And so let's do that. I might need to take this line out a little bit, actually. I think I'll do that, because you guys can see that line if I go out. Yeah, if I go out with that line. And I think what I'll also do is I'll grab both of these and I'll move them over. There's a lot of setup when you're making your graph, but this part is important too, so hang with me here. If you want to fast forward a little bit, I don't blame you, but it's also important to know how to properly draw your graph. There we go. That's pretty well aligned. Yeah, that looks good on your end as well. Okay. So now it'll be 2 pi. So I actually made that a little bit longer than I need to, but I figured 4 spaces is good, because then it's like you can take half and then you can take half again. Also because I'm going to be shrinking it down by a factor of 4 with this guy right here. Okay, so now that we've set that up, oh, and then also the amplitude gets stretched out a little bit. But since one of them is stretched out by a factor of 3, 1, 2, 3, 4, 5, 6, yeah, we can go by 2s. So 1, 2, 3, and then down here, negative 1, negative 2, negative 3. For sine and cosine, their original periods go from 0 to 2 pi. And then typically when you shift them around, the only thing that would make it so that they don't start at 0 would be if you were to shift it to the left. And we don't have any phase shifts. So I'm not really worried too much about what's going to be on the left side. So I'm not going to really label that side. But it would be the same as the right-hand side. So, all right. So let's go ahead and just graph y equals sine x. And I'm going to use a t-chart to graph this because we want all the typical values of sine x. And all the typical values and places to look for are always going to be a quarter of whatever the period is. So the current and the default period is 2 pi, which, by the way, is because it's one full circle. It's one full turn is 2 pi radians. So a quarter of that gives me all the important values. So a quarter of 2 pi is pi halves. So that's why I'm going by pi halves. Then I have pi, 3 pi halves, and 2 pi. Okay, and actually, you know what? I might move this a little. You know what? No, I want to move this. Actually, I want to move it kind of out of the way. I'm going to move it over here. Yeah, so that way you guys can still see it. And I think I might actually copy this because we're going to need 2 of these. Or I'll just make another one for the next video. Thinking too far ahead here. So the sine of 0 is 0. The sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves is negative 1. And the sine of 2 pi is 0. And those are all just unit circle values. So those are values that I have memorized. If you don't have those memorized yet, I hate to be like, oh, just memorize it. But I mean, yeah, they kind of expect you to know those values. So it is what it is. So those are our values for y equals sine x. And then here's what we do in order to get y equals 3 sine 2x. We just go one by one, and we apply the transformations. If it's outside of the grouping with the x stuff, then it affects y. And it does exactly what it looks like. If it's inside the grouping with x, it does exactly the opposite operation of what it looks like it does. Okay? So if you need me to say that again, you can just go back in time a little bit, because that was really important. But we're going to start with the 3. So there's 3 sine 2x. I'm going to times all my y values by 3. Okay. And then 2x. 2 times x is 2x. So I'm going to divide all of my x's by 2, aka times by a half. 1 half, 1 half, 1 half, 1 half, 1 half. And what does that give me? Okay, so that would give me, actually, you know what? Let me do this. I want to graph the graph of sine x as well. We'll overlap it. So the graph of just sine x by itself would go like this, and then here, and then here, and then here. So here's one period of sine, and I'm going to draw it a little bit lightly because they're not really asking for sine x. It's just sort of like something to reference to. And you might not even want to draw sine x there unless you're saying that like you're just, comparing it to those. And if you're like color coding everything like I am, then maybe that'd be fine. But I wouldn't graph both of them in pencil because the teacher might be like, oh, they're just trying to graph 2 because they're thinking like one of them might be right. So they're trying to like make sure they cover their bases or something. I don't know. But don't give your teacher any excuse to mark you wrong. So if I graph the new points, it would be 0 times a half, which is 0, and then 0 times 3, which is also 0. So my starting point is still going to be 0, 0. And again, this is for my graph of y equals 3 sine 2x. Okay. So next point is going to be pi fourths, comma 3. Well, if this is pi halves, then half of that would be pi fourths. So this is pi fourths, comma 3. And then if you notice, I'm going by pi fourths. So my next value should be pi fourths. My next value should be 2 pi fourths, right? So 0 pi fourths, 1 pi fourth. This is going to be 2 pi fourths. That's pi halves. That's 2 pi fourths. I'm going by spaces of pi fourths. You don't necessarily have to do this math every single time once you see the pattern. So I'm traveling from 0 to pi fourths. So I'm going to keep going by the same amount of spacing, if that makes sense. So my next y value is going to be 0, so that's going to be right here. And then my next y value is going to be -3, so it's going to be way down here. And then my next value is back to 0. So notice that the period got halved. So 2x means I'm halving my period. It was actually a horizontal shrink. And then the 3 in front of the sign was a vertical stretch. So I'm going to attempt to sketch this now. Sketch this as best as I can here. There we go. And of course, there's arrows on both because it goes on forever and ever and ever. Okie dokie. So that's how to do that one. You know what? We might as well go ahead and do both. I was gonna split them up, but it takes so long to set up the graph that I might as well just go ahead and finish off the other one. So we'll go ahead and finish off the other one as well. So the other one will be y equals 2 sine of -4x. Okay. And with the graph of y, you could write it as a negative inside of the parentheses, or you could write it as a negative outside of the parentheses, and it would actually be the same thing. So that's actually the same thing. You know what? I'm gonna write this over here though, because I don't want to confuse you guys. But it would be the same if I were to graph it that way. So I'm gonna actually leave it in its current form when I go to graph it. And if you noticed that the yellow marker was a little bit thicker than the blue marker, that's just because yellow is typically lighter. If I'm drawing on a white background, yellow doesn't contrast as well, so I have that yellow marker a little thick. I don't know if you guys noticed or not. But anyways, so yeah, so actually I'm going to go ahead and copy over the yx for sine, because I have the sine as a parent function again. So pi halves 1, pi 0, 3 pi halves -1, and 2 pi 0. And then I'm going to take and do the exact same stuff all over again. So there's a 2. I'm going to times all my y's by 2. Times 2, times 2, times 2, times 2. And I'm going to times all of my x's by -1/4. So actually, that's going to make my x's negative. Maybe I do want to make it so that the y is negative instead of the x. You know what? I'll do a little bit of both just to show you, because this graph is going to get really shrunken down anyways. So I'll do both actually to show you that it's actually the same thing. So if I graph those points, that's going to be 0, 0. So that one starts at 0, 0 as well. And then that's going to be -pi8, comma 2. So remember, every 4 spaces was the pi halves. So half of that would be pi fourths and half of that would be pi eighths. So every single grid line that you guys can see is a pi eighths. So I already kind of had that planned to do it that way. And that's going to be up to 2. So that's going to be right there, right where I wrote the number 1, pi by 1. So it goes right there. Oh, just kidding. It's going to go up to 2. I was testing you. Ooh, it's trying to draw a circle. No, I don't want to draw a circle. Sorry, Microsoft Whiteboard. It will randomly predict what I want to try to draw, but it's not consistent, so I don't try to use the feature. Okay, the next one is going to be -pi4, comma 0. So remember, every space is a pi8 space. That's going to be right here. I don't really need to keep doing that math, right? Because it's going to be the same amount of spacing every time. And then I'm going to go down to -2. It's going to be down to here, right there, and then back up to 0 right there. Okay, so this is going to graph like this. There we go. Okay, so I'm going to leave off the other arrow because I'm actually going to show you what that would look like. What if it was the other way around? What if I had times my y's by -2? So then that would be 0 times -2, still 0. 1 times -2, 0 times -2, -1 times -2, and 0 times -2. So what if I times my y's by -2 instead? and I divide my x's by a positive 1/4. So that'd be 0 times 1/4 is still 0. That would be pi halves times positive 1/4, so that'd be pi eighths. Pi times 1/4 is pi fourths. 3 pi halves times 1/4 would be 3 pi eighths. And then 2 pi times 1/4 would be pi halves. Which, remember, pi halves is right there. So I'm going to be done by the time I get halfway across one period of the yellow graph, or a quarter of the way across the parent function. Okay, so let's graph that. So it'd be 0, 0. We already have that graphed. Pi eighths, comma, -2. Pi eighths, -2. Pi fourths, 0. Okay, 3 pi eighths, 2. Right about there. And then back down to 0 at pi halves, 0. So notice that it's the same exact graph. It's just a different portion of the graph that's getting graphed here. So if I just continue the graph that I already started graphing from earlier, I'm actually getting the same exact curve. Because remember, these arrows tell me that it keeps going forever and ever. It's an infinite wave. It's a wave that never loses any energy. It's an infinitely conserved energy wave. So there you have it. So some teachers like you to try to take the negative out of the sign and put it in the front. Some people don't care. Because sine is an odd function, I can take that negative and put it in the front of it, like I did right here. Okay. If it was cosine, then the negative would just go away. If I wanted to take the negative away, I could just take the negative away out of the inside area with the x. And that's because it's an even function. So if that's a little confusing, that's like kind of outside of the scope of this exact video here. That would be under like even and odd functions. Sine's an odd function, cosine's an even function. We can talk more about that in other videos. But we'll wrap it up now, and that's about it. Hope that's been helpful. If you want to check out other things, I have other videos on here. I'll put a link to other pre-calculus, my pre-calculus playlist on here, so you guys can see that and see other videos that are in the same class as this. As well as if you want to check out my website, I have some content on there, like the 5 math mistakes everyone makes and how to avoid them. So you can check that out. It's a free PDF I have on there, along with some other content. So lots and lots of stuff. I'm trying to make stuff every day to help this specific student and other students as well. So check it out. Hope it's helpful, and I'll catch you in the next video real soon.